See, I'm just making it clear that whatever is needed for the prelims, everything is being done. First, I told you in the beginning as well that you ask any topper what you have to do for prelims. They'll just simply tell you four things. First, they'll tell you read the standard books. Solve the PYQs. Parallelly, you should not skip PYQs and read the standard books because you won't get to know what you have to focus exactly in standard books. So now in a book a week program, we have ensured that whatever you are studying, okay, is right and relevant for the examination. That's why parallelly in the class itself, what PYQs have come and where you have to emphasize and how to memorize or remember, we have learned. Okay, especially with respect to history spectrum and Indian geography. And along with this, what are the other two things they'll be saying? Cover the relevant current affairs. Current affairs should only be your secondary thing, not the primary thing. What people do, they overemphasize. Okay, they overemphasize the current affairs, and after a point of time, they realize that they cannot master current affairs at any point of time. Sir, key direction. Yeah, so you can't master current affairs at any point of time. So that's why whatever the important subjects that are there, economy, IR, science and tech, environment, okay, mapping. So these things you have to focus, and that too very relevant ones and important ones, because you can't study everything that is happening. However, what we are trying to do is to keep it comprehensive to large extent. We are covering them. Okay. So now they'll ask you to cover current affairs, and the last one is to give tests. If you miss current affairs, still you have a chance of clearing the examination. Okay, because from the test you learn the current affairs that are important. But if you miss any of these three, there are very high chances that you may face the struggle in the final day examination, which might be counterproductive to your entire process, because you know you are capable of doing, you have all the potential, you are ready to sit and study, then why choose the wrong direction? It is very important to give tests, and if you skip this part, that means assume you are not preparing for this examination. Since beginning, day one, I always emphasize, be it anthropology, be it optional GS mains or prelims, practice is the key. Even for interview also, practice is the key. For all the stages, I told you that 30% of your time should go for practice, because it is reverse learning. It's not like you are just reading it. See, by solving it doesn't mean you are not learning anything. By solving the questions, you tend to learn more than what you read directly. So that's why don't avoid tests. All the current affairs that are needed, I'm telling you again, for economy, for science and tech, for environment, and along with that, IR mapping will economy also. So everything, we will be ensuring that all the current affairs are covered. You don't need to worry about them. So don't run after the things, and especially I'm telling you again, you cannot master the entire current affairs. So that's why whatever you are reading, just make short notes of it, revise more, write the test, and then if you come across a question, if you don't know the question, if you haven't read in current affairs, then make the notes out of it. Okay, use tests for learning purpose, and it is not to judge yourself. But from the test, what you can learn how to sit focusedly for 2 hours, whether you are able to recall what you have read already, and you might be thinking you are confident in some of the topics, but still you might go wrong. So such mistakes if you are committing, and sometimes you may not read the question properly and you might answer it. So then after coming out of the exam hall, you'll realize that this question, you know it, but still just by reading the question wrongly, you did it wrong. So now to overcome this, you have to give tests, and only way to overcome is by giving the test. So tomorrow, if you have to not regret on the final day that I have committed silly mistakes, or else I would have gained another 10 marks or 5 marks, then do not skip the test. I have seen some of the students, they are skipping the test, but this is very serious mistake which you should be avoiding at least from now, because already spectrum is done. See, the tests are sectional also. Day 1, 2, 3, 4, 5 you have done. Each day you have one test. Just complete that day revision and attempt the test. Similarly, science and tech as well. So I would suggest sir will be covering the current affairs very detailedly. So if you have any doubts, even with the static part, which is very relevant, because you know in science and tech most of the questions go wrong because people don't understand the concept. It is not because they don't know the current affairs. They know the current affairs, they have read it, but they don't know the meaning of the statement that is given. And because of that reason, they'll go wrong. Because science and tech, you can't rote learn. You have to understand. So for that, the classes will be very helpful. And if you have any doubt, you can ask sir. Sir will be helping you in overcoming them. Okay. So you have got the schedule of science and tech, right? So science and tech, it is bit lengthy. Okay. So I want you to be patient enough for the next coming 5 days. Okay. So be patient enough for 5 days, and the classes are going to be for 4 hours. Okay. 10:30 to 12:30, then again from 2 to 4. Same is for the environment also. Because if we want to finish it in 15 hours, we can do it. We are extending it only for the reason that let the coverage be comprehensive. So that after the class, you just have to revise what is done. Maybe 1 or 2 topics will be left. Not that you have to go and read another 100 pages again. Okay. So that's the reason that the classes are for almost 4 hours a day for 7 weeks. For 7 days. Okay. So 10:30 to 12:30 and 2 p.m. to 4 p.m. The same schedule goes for environment also. This is Feb 5 to Feb 12. So during this, what you have to be focusing, first understand what is being taught in the class. Already PPTs will be shared with the students. Okay, so you have the PPTs. So immediately after the class, revise and solve the PYQs, and even sir will be making you solve the questions here. You will be having practice questions. So solve the PYQs, and you have the test. So just give the test directly after the topic. Okay, so maybe you might be committing more mistakes in the test. No problem, because we are giving tests to learn, not to judge ourselves that how much we are scoring, where we stand, but whether whatever we have understood in the class, are we able to apply, and where are we going wrong. If you are going wrong in some topics and there is a difficulty in understanding it, then you can ask sir the next day that this is the area where you are facing the difficulty. So he will be available after the class to clarify your doubts. Okay. Even environment also, the coverage of current affairs is going to be very detailed. Very detailed coverage is going to be done. So need not worry about the current affairs part. And as I said, IR we have after environment and science and tech, because I wanted the things to develop further so that we can cover all at a time. Okay, at least till February 15th or 20th. So this is till 20th, right? So you have another week for environment. So almost February current affairs also we can finish. Till February, if you are ready with IR, only 2 months of IR part will be left. Okay, so till April if you are ready, I think that is sufficient. So now sir will be taking the class. He will be coming in 2 minutes. You have any doubts with respect to prelims, or if you want something to be added or any difficulties that you are facing, If you can let us know, then I'll be trying to help you in that aspect and ensure that your prelims preparation is smooth. So if you have anything, you can, online students, you can do let us know in the comment section. So if you have some problem, this is the area we are facing some trouble. Okay, so there will come up with some initiative to overcome it. So just go through, analyze yourself, and if there is any problem, you can do let us know. So we'll help you with that, and soon we'll complete it. So by February end, we'll try to cover the most of the things. Okay. So after February, March, April, and May, our focus will be on revision and practice of the test. Okay. So now, sir, sir, yeah. So everyone, here you have Apu Tiwari sir. So he is from Delhi, and he has 8 years of experience in this teaching. Today he'll be taking science and tech. I think you already know it, but just introducing because he is here for the first time.
Good morning, all of you. Sir has already introduced. I passed from NIT Bhopal from 2011 itself. I worked in Samalkota, East Godavari district for 4 to 5 years, and there I have 2 patent registered on my name regarding the increasing the efficiency of cooling tower after they prepare for UPSC 2 mains interview, and finally back into the coaching sector. I have been associated with this coaching sector from last 8 years. Okay, multiple institutions in Karol Bagh, and apart from that, I have been also associated with IITs. Sometimes IIT Delhi's, okay, IIT Jammu. I used to take the classes of science and tech itself, science and tech environment. Is it? So we will be starting it now. My PPTs, they are itself sufficient. No need to refer any sort of books. At this point of time, at this juncture, it's not possible to read any other aspect. So my PPTs, it will be sufficient. My PPTs, they will be acting as a notes. Is it okay? And apart from that, the main aspect is that whatever I will be writing on the boards, that will be very much important. I used to teach in an integrated way, because when you go and analyze the UPSC paper, it's like they are not going to ask what is neutrinos. A simple one-liner statement they won't be asked. Rather, what it will be asked in an integrated fashion. What is neutrinos? For example, India-based neutrino observatory. Okay, have you know about it? What is that? India-based neutrino observatory. Basically, they are being developed for the purpose of studying neutrinos. Is it okay? But it will be developed for the purpose of studying cosmic neutrinos. That means what? The neutrinos that is being released from the sun. And sun, when you talk about the neutrinos, it's of 3 types: electron neutrinos, Mao neutrinos, tau neutrinos. But when you talk about the sun, it releases specifically electron neutrinos. So if in the examination questions comes like specifically for the purpose of capturing and studying what? Electron neutrinos, that statement, it will be perfect. So my board, it will be very much important. Okay. Okay, so we will be starting with universe and particle physics. If you go through the UPSC Prelims paper, you can see that approximately 2 to 3 questions they are being asked from universe and particle physics. Okay, so all sort of basic fundamental concept I will be discussing. Okay, and whenever I feel like we have to go for the integrated concept, okay, it will be discussed in the boards. So आप सभी के पास notes हैं? Is it okay? It's your responsibility to just synchronize with me. ठीक है? Believe me, if you are attending my classes, 80 to 85% of the questions it will be directly solved. Clear? So when you talk about universe, okay, so in the universe, matter is not homogeneously distributed. For example, when you talk about this is the universe, and somewhere you can see what? This is a galaxy. So galaxy means what? Lots of stars, it will be there. Dark matter, it will be there. So obviously what? Matter is concentrated in this particular portion, but here it's an empty space. So matter is not homogeneously distributed. Have you received my PPT? Yes. Okay. Now, when you talk about the structure of galaxies, okay, so when you talk about the structure of galaxies, they are being defined on the basis of the structure, what type of structure they have. For example, when you talk about the Milky Way is what? It's a spiral shaped galaxy based on the structure. Similarly, we have elliptical shaped galaxies, irregular shaped galaxies, and spiral galaxies. Now, when you talk about Milky Way, okay, so Milky Way. Is it okay? So it's a what? Spiral shaped galaxy. Okay, this is what Milky Way. Now here what we have? Sun. This is the location of our sun, and because of this here we are having our solar system. Solar system. Is it okay? Now in the center of the Milky Way, in the universe, remember one thing, in the universe, each and everything it is rotating around something. For example, what is the definition of satellite? Satellite definition, which revolves around a particular celestial object. For example, moon is a satellite with respect to earth. Earth is also a satellite with respect to sun. Sun is also a satellite with respect to this particular star. Okay, now this was a star, but this star, it has been converted into what? Black hole. It has been converted into what? Black hole. And what is the name of it? Sagittarius A. Is it okay? Clear? Now this is what Milky Way. Now Milky Way belongs to a galaxy cluster. Galaxy cluster, that means what? Lots of galaxies, they will be what? Coming together. Lots of galaxies, they will be coming together and they will be forming what? A galaxy cluster. So when you talk about the galaxy cluster, this is a galaxy cluster. It has 33 galaxies. It has what? 33 galaxies. 33 galaxies means what? 33 galaxies are there. And out of this is what? This is our Milky Way. Clear? So what is then? This is called your galaxy cluster. This is called your what? Galaxy cluster. And what is the name of it? It is called local group. It's called what? Local group. Are you getting my point? So when it's there in your notes, when you talk about Milky Way, it's a galaxy. It belongs to a galaxy cluster. Galaxy cluster means what? Lots of galaxies. They will be what? They will be together with the help of dark matter. We will discuss. Lots of galaxies. They will be what? Held together. So when you talk about this galaxy cluster, it comprises of 33 galaxies, out of which Milky Way is the one. And what is the name of it? Local group. इसे क्या कहते हैं? We call it as local group. Okay. Now lots of galaxy cluster, they will be forming another cluster called super cluster of galaxies. Called super cluster of galaxies, and we call it as what? Virgo. We call it as what? Virgo. Is it okay? Now, you know about Mahabharata a bit. Mahabharata, written by Ved Vyas. Ved Vyas has basically dictated it. It was been written by Lord Ganesha. Is it okay? So, wahan pe if you go, you can remember one theme from it. When Lord Krishna went to Hastinapur for the purpose of what? Seeking peace. For the purpose of what? Seeking peace as a peace advisor. Okay, he has stated his power. He said that, Duryodhana, what's your power in comparison to the Virgo? What's your power in comparison to the local group? What's your power in comparison to the Milky Way? In the Milky Way, sun, again, apart from that 9 planets, like this, and it's in Sanskrit, I can recite it. Okay. This thing. Now, this is very much important. You knew from this particular portion question it will become. when you talk about the universe mass composition. Okay, so here you can see that heavy element, it comprises of 0.03%, neutrinos it comprises of 0.3%, star it comprises of 0.5%, free hydrogen and helium it comprises of 4%, dark matter how much? 23%, dark energy how much? 72%. Okay. Okay. Now, how do we study celestial objects, celestial events? Suppose if you want to study a star or some particular star, how it can be studied? Suppose if you want to study a particular star, how it can be studied? How we are going to study the celestial object? What is the mechanism? With the help of observatory. Observatory, what they will do? Okay, see, UPSC, when you talk about the UPSC, they will ask you the basic fundamental concept of it. If your basic fundamental concepts are okay, if any sort of question it will be asked, you can solve it. Okay, so how we study the celestial thing? Surface area. How you are going to calculate the surface area? Okay, write it down. Study of celestial objects. Okay, its mechanism. How do we see anything? How do we see anything? What is the mechanism? How do we see anything? What is the mechanism? Reflection of light. Is it, for example, this laptop, it is visible to everyone? Why it's so? The basic principle is what? It is the reflection. Lot of luminous sources are there. Lots of light sources are there. They are what? Emitting the light. This light, it is going to strike the surface. After that, what? It will send its reflected ray. Now those reflected rays, they will pass through our eye lenses. They will strike what? Retina. Image is not formed on the retina. On the retina, we have what? Rod and cone cells are there. Rods and cone cells are there. Now this light, they will strike these rods and cone cells. These rods and cone cells, they will get excited and they will release specific frequencies. Okay, those frequencies, they will move through our optical nerves and they will be studied by the brain. And finally, the brain forms the image. Our brain is a what? It's a quantum computer. You go in Amravati, quantum area has been developed. Quantum, our brain is a quantum computer. Are you getting it? This is the mechanism. Similar thing will happen into the space also. Direct observation, suppose there is a particular star. That star, either it will be emitting its light or deflecting the light. Those lights, they are being captured by our observatory. It's the direct observation. Okay. So first is what? Direct observation. On the Earth's surface, what we have? Telescopes are there. Telescopes. Even in the space also we have telescope. This is what? Hubble Space Telescope. Hubble Space Telescope, and apart from that we have what? James Webb Telescope. Is it? Now, direct observation means what? Suppose this is a particular star. Either it is emitting its light, it will be directly studied by this telescope, or if it do not have its own light, it will be what? Reflecting the light. So this is called the direct observation. Direct observation means what? Observatory, telescope, Hubble Space Telescope, James Webb Space Telescope, they will be capturing the light directly emitted from that particular celestial object or reflected from that particular object. It's called the direct observation. Okay. Second, indirect observation. Indirect observation. Okay. And direct means what? Now, what is Newton's law of gravitation? Newton's and NCERT class 9th. Newton's law of gravitation. Each and everything in the universe will attract each and other thing in the universe with a force that is called the force of gravity. है ना? If we talk about the two bodies, they are going to what? Attract each other with a force called gravity. So definitely, if this is a celestial object, this is what? This is your celestial object. It will have mass, is it? It will have gravity. Okay, so when you talk about indirect observation means what? Effects of gravity. Effects of gravity. Are you getting my point? Effects of gravity. Is it? Effects of, with the help of effects of gravity. Effects of gravity. Now, in the direct observation, see, UPSC has not explored this particular portion. Always remember, you see often after the prelims examination, students often complain that we have studied all sort of current affairs, but the questions are not being sorted out from there. What is the reason? Because UPSC, when you talk about the UPSC, it do not directly copy the statement. Okay, it will capture the inherent concept. In the direct observation, you can include gravitational waves also. Gravitational waves. Have you studied about the gravitational waves? When you talk about we will discuss gravitational waves. They are also being included in the direct observation. This is what? It has released some of the gravitational waves. Now these gravitational waves, it will be captured by, if these gravitational waves that are being generated, if I have certain equipment for the purpose of capturing it, I can know what was the event. It was the clapping. My sound also generates gravitational waves. Is it? So I have a particular equipment that can capture the frequency of the gravitational waves. And we can know what was the event. So in the direct observation, gravitational waves are also being included. The waves that are being created by the disturbance of energy. It's called what? Gravitational waves. In the direct observation, you can also include what? Gravitational waves also. Because we have a particular observatory called LIGO observatory for the purpose of detection of gravitational waves. See, I will be a little bit faster because it's a prelims crash course, is it? And apart from that, I have decided that in the prelims crash course, all sort of fundamental concept it will be discussed. So I will be a little bit faster. You have to. Okay. Okay. Now going to prepare the ordinary matter. Ordinary matter. So we have discussed that about 70 to 75% of this matter is hydrogen and about 25% is helium. When you go through the universe mass composition, you can see that 4% is what? Hydrogen and helium. 4% is hydrogen and helium. And out of that, you can see that 70 to 75% is what? Hydrogen. 70 to 75% is what? Hydrogen. Rest is what? Helium. Now, hydrogen is a what? It's an element. Do you think it can emit light or it can reflect light? Is it? See, when you talk about we are talking about the ordinary matters, hydrogen, helium, even the radioactive metals, that the radioactive element that is present inside the universe. So when you talk about this particular ordinary matters, hydrogen, helium, they can be what? Directly studied. They can be what? Directly studied. And just now we have discussed that when you talk about the direct observation, it can be done with the help of light. If that particular celestial object, if it emit light, if it reflect light, we have the telescope for the purpose of studying it. So when you talk about the ordinary matter, they can be directly studied. Why so? Because ordinary matter, they emit or reflect light. They emit or reflect light. Do you know how is it possible? You know the concept of fluorescence? What is fluorescence? Fluorescence. Concept of fluorescence. Suppose this is a particular element. Is it? So ordinary matter, they can be what? Directly studied. It can be what? Directly studied. Okay, it can be what? Directly studied. Directly studied. See, why so? Because it emits a reflect light so that we can detect the radiation coming from it. And it has gravitational effect also. It has gravitational. Obviously, ordinary matter, it will be having its mass. If it is having the mass, it will have gravitational effect also. Now, what is the principle? The principle is what? Suppose this is an element, okay, or this is an atom. Better to say atom. This is an atom. Okay. Now this is the electron. This is what electron. If you go through the NCERT, different atomic models are there. J.J. Thomson's model, the Rutherford atomic model, and finally what we have? Bohr's atomic model. When you talk about the Bohr's atomic model, it said that we have a nucleus. Inside the nucleus, what we have? Protons and neutrons. And apart from that, the orbit, it's called discrete orbit. It's called what? Discrete orbit. Why so? Because the electron revolving around this particular fixed orbit, it will have constant energy. It will have constant energy. When you talk about the Rutherford model, it said that the electron, while revolving around the nucleus, what will happen? It will lose energy. If the electron will lose energy, what will happen? Suddenly, the electron will fall on the nucleus itself, and because of that, that model was criticized. But when you talk about the Bohr's atomic model, it says that the orbit is what? It's a discrete orbit. Discrete orbit means what? It will have fixed energy. That means what? Electrons, while revolving around this orbit, it will have constant energy. Now, what happens? Suppose this is the X-ray radiation. This is what? X-ray radiation. When this X-ray radiation, it will strike the electron, what will happen? The electron will gain the energy, and after gaining, it will move to the higher orbit. But it cannot retain the position over there. It has to come back to its ground state. When it will be coming back to its ground state, what will happen? It will release the extra energy. It will release the extra energy that was being absorbed. And this phenomenon is called what? Fluorescence. Are you getting my point? So when you talk about ordinary matter, for example, hydrogen and helium, 4%. Now they are being dispersed into the space. Lot of luminous sources are there. Now those luminous sources, when they will strike this particular hydrogen atom, what will happen? The electron will move to the higher orbit. It cannot retain the position over here, and finally what? It will switch back to its ground state and will release the energy in the form of fluorescence. So ultimately, that fluorescence, the light that is being emitted, that will be captured by the telescope. Is it okay? What's your background? Just let me know. Science background. Anyone from science background? Engineer. NIT Jaipur. Okay. BSc. BTech Computer Science. No. Engineering. Sorry. BSc. So I hope all of you are from engineering background, and definitely you can understand this concept. Is it? समझ में आ रहा है सभी को ना? Is it okay for everyone? Okay. Now dark matter. Just try to understand the concept. Now when you're talking about the dark matter, it is dark. Dark means what? It is not going to emit light. It is not going to reflect the light also. And because of that, it is not feasible for us to go for the direct observation of this dark matter. Hence the name, it is dark. Still, it is dark in nature. But we are talking about the matter. What is the definition of matter? Anything that is having mass and occupies space. That means what? It is having the mass. If it is having the mass, that means what? It will have its own gravitational effect. And with the help of those gravitational effect, it has been studied that when you talk about the universe mass composition, how much gives around 24% of the masses of the universe. Okay, it is dark in nature because we have failed to study it. We have failed to study by the direct observation because it is not emitting or reflecting light, but still it is present. It is having the mass, and because of that, it is having gravitational effect. And because of the gravitational effect, it has been studied. It has been studied, and we found that approximately 24% of the universe mass it comprises of dark matter. Okay. So its existence is inferred from their gravitational effects on the rotational speed of the galaxies and inside the galaxy cluster. For example, when you talk about galaxy, when you talk about the dark matter, it is just write it down. Dark matter, it is responsible for what? It is responsible for gravity forces. What? Gravity forces. When you talk about the dark matter, 24% it is present in the universe. It is responsible for the genesis of gravity forces. For example, when you talk about galaxy cluster, is it galaxy cluster? In the galaxy cluster, what we have? For example, local group. 33 number of galaxies are there. So obviously, how those 33 number of galaxies they are being held? There will be certain forces, and what is that force? Gravity force. This is what? Gravity force. And why those gravity forces? Because when you talk about the galaxy cluster, a lot of dark matter present over there. We have already discussed the 24%. Yes, let me know. Can I off it? This fan. Yes. Go ahead. No, it's not. It's not. Okay. Are you getting my point? Dark matter. So it's a matter. It do not emit or reflect light, so it cannot be studied with the help of direct observation. But obviously, it's a matter. What is the mass? 24%. Obviously, it will have higher gravitational effect, and with the help of the gravitational effect, it has been studied. For example, when you talk about the galaxy cluster, lots of galaxies are there. Now those galaxies, they will be held together, and because of that, there will be certain forces responsible for it. What is that particular forces? Dark matter. So when you talk about the galaxy cluster, lots of your dark matter are there. Those dark matter, they are responsible for what? Generating gravitational forces, and because of the gravitational forces, we have those galaxy cluster. We have even galaxies also. In the galaxy, lots of stars are there now. Is it? Now, when you talk about the dark matter, it is highly weakly interacting particle. Just listen to my concept. It is highly weakly interacting particle. Weakly interacting means what? They are not going to interact with anything. They are not going to interact with anything. Okay? And because of that also, it is very difficult to study those dark matter. We have two such things. One is the dark matter and other is what? Neutrinos. Have you studied about the neutrinos? Neutrinos, when you talk about the neutrinos, they are highly interacting weakly particle. Highly means what? They are weakly interacting particle. They are not going to interact with anything. For example, presently in the classroom also we have around crores and crores of neutrinos. They are crossing through our body, but we do not have any effect. Even the atoms, the biomolecules, they are not absorbing any sort of neutrinos. And when you talk about the neutrinos, they are called the weakly interacting particle, highly weakly interacting particle. Why so? Because neutrinos are what? Chargeless in nature. Suppose if certain thing is positive charge, obviously what? It will be attracted toward the negative charge, or it will get deflected from the positive charge. Is it? But when you talk about the neutrinos, it is weakly interacting. Why weakly interacting? Because it is chargeless. It do not have any charge. Okay. When you talk about the dark matter also, dark matter is also what? Weakly interacting in nature. Is it? So for the purpose of studying dark matter or neutrinos, okay, suppose you have two friends. You have two friends. One is highly interacting in nature. They will interact frequently with the chai wala, samosa wala, and friends, whatever it is, phone, this, that. So suppose मान के चलिए कि अगर आप ही का फ्रेंड्स का किसी की बहन की शादी करना हो, तो बोले उसके बारे में बताओ. Obviously will come to know. सबको पता है. But एक है जो किसी से बात ही नहीं करता है. He will come, sit in the office, sit in the classroom, and directly is not going to interact with anyone. Now, how to study? How to study that particular person? कैसे? in the completely isolated atmosphere. है ना? मतलब it is against privacy, but what we should do? उसके रूम में CCTV कैमरा and just monitor him. है ना? Okay, so what I mean to say when you talk about the dark matter or neutrinos, they have to be studied in the isolated fashion. Now suppose dark matter, weakly interacting in nature. Since it is weakly interacting in nature, it is not going to interact with any other things, so it can directly reaching on the Earth's surface. Even it will cross our Earth's surface also, Earth's surface mantle also. And because of that, when you talk about the dark matter observatory or neutrino observatory, they will be developed in what? Underground. They will develop underground. Why underground? Because all sort of other elementary particles, they will be what? Filtered away. Only dark matter and neutrinos, since they are weakly interacting in nature, they will be directly reaching to the underground observatory. So for the purpose of studying this dark matter, we have an observatory detector that is called LZ detector. This is the LZ detector, Lux Zeppelin detector. Okay, it is being particularly designed for the purpose of capturing what? Dark matter. It consists of a huge titanium tank filled with the extremely pure liquid called xenon. Center of LZ is the one of the purest place on Earth. It is one of the purest place on Earth, so that what we can study this dark matter. Okay. Collaboration of scientists institutions from US, UK, and Portugal and Korea. India is not participating in this particular project. So now when you talk about the dark matter, it's of just a moment. Okay. So what we have discussed, dark matter and neutrinos, they are more or less weakly interacting particles. So when we talk about the LZ detector, it was being designed for the purpose of capturing what? Dark matter. But we have seen that when you talk about the neutrinos, they are the most fundamental elementary particles, most abundant particle. So when you talk about this LZ detector, it has been designed so that what? It can capture dark matter. But what? It has captured a lot of neutrinos. That means what? That particular tank, it should capture the dark matter, but it has captured all sort of neutrinos, and it was being completely filled with the neutrinos. And this problem is called what? Neutrino fog. For example, it has not been asked in the UPSC Prelims. If it is being asked that it is difficult to study dark matter because of neutrino fog, the statement it will be correct, because whenever we talk about any sort of detector, it will be developed underground. It has to capture the dark matter, but along with the dark matter, it will also capture what? Neutrinos. Why so? Because neutrinos is also weakly interacting in nature, and this particular phenomenon is called what? Neutrino fog. The tank, it will be completely covered with the hazy fog of neutrinos. Done? The same thing. Neutrino fog refers to the background noise interference created by the vast number of neutrinos produced in the universe, particularly from the cosmic sources like the sun, supernova, and astrophysical phenomena. We will discuss when you're discussing neutrinos. They will be discussed that, for example, we have discussed when you talk about the sun, it releases what? Neutrinos, particularly electron neutrinos. Now, when you talk about dark matter, presently it's of three types. Okay, first is what? Scientists have created a detailed dark matter by using microwave detector of the Atacama Cosmology Telescope. First is what? WIMPs. One of the favorite dark matter candidate that possesses a lot of mass, but it will have barely interact with the normal matter. That means what? It is having a lot of mass because we have seen, but it is not going to interact with any sort of matter. Second is what? Axioms. Another theoretical particle. That means what? It may be present, it may not be present, but we have what? Given the name axioms. So another theoretical particle that interacts more weakly than the WIMPs. It possesses far more less mass, which make it even more difficult to pin down the more massive rivals. Gravitinos, it is theoretical. More massive partner of the particle that is thought to carry the gravitational forces, the graviton. Okay, we'll discuss. One more you can add over here. Asteroidal neutrinos. First of all, it's a neutrinos. It's a what? Neutrinos. Obviously, it's a weakly interacting particle, and apart from that, we have added what? Sterile. That means what? It is not going to interact with any sort of matter, and because of that, it is also being considered as a dark matter. Now, dark energy. Dark, yes. No, we have not discovered it. Okay, that's why I have written theoretical particle. If it is being detected, see, we have started developing the detector so that what we can capture the dark matter. We have already detected the first one, WIMS itself, but when we talk about the axioms and gravitinous, we have failed to detect the world because of neutrinos fog itself. Okay. Okay. Now dark energy. This dark energy. So what is we have discussed with universe mass composition. What is the percentage of it? 72%. So remember my word, when you talk about the dark energy, it is responsible for anti-gravity forces. It is responsible for what? Anti-gravity forces. Dark matter, gravity forces 24%, and dark energy how much? 72% anti-gravity forces. So if you compare both dark matter and dark energy, which will be greater? Dark energy. That means what? Anti-gravity force is what? Dominant, and because of that, universe is what? Gradually expanding. But see, one thing you must remember, there are two terms. It is homogeneously distributed. So remember, dark energy is homogeneously distributed and it is stable in nature. If it is not homogeneously distributed, what will happen? This side it will expand more, and this side expansion it will less. And apart from that, it is stable in nature. So that what? We will see gradual expansion. Okay. So the universe is expanding because of dark energy. Why dark? Again the same thing, because it do not emit or reflect light, and because of that we have studied this dark energy because of using what? Its gravitational effect. Big Bang theory. Am I fast? Is it okay for everyone now? Because it's a prelim crash course and I have to complete all the syllabus. Okay. So wherever I feel that I have to go on the board, definitely I will be using the board itself. Now, anybody is having any idea regarding Big Bang theory? Big Bang theory?
The point where all matter was went in.
Okay. Is it? So, see, this is the timeline. First, there was a point called singularity. It was holding the complete mass of the universe. And since it was holding the complete mass of the universe, the temperature, it was very much high. It was more than 10 to the power 45 degrees Celsius. And for that singularity to remain stable, it is not feasible. And because of that, it exploded. It exploded, and that is called the cosmological inflation. So when it exploded, it has released all sort of fundamental elementary particles. Fundamental elementary particles. When you talk about electron is fundamental elementary particles. Protons and neutrons, they're not the fundamental elementary particle. We'll discuss. Okay. So we had this event. It has taken place around 13.8 billion years ago. 13.8 billion years ago. Okay. So we are discussing within the time frame of 1 second. When that within 1 second, the temperature it was very much high, 10 to 13 degrees Celsius. And in that, only quarks they have what? Interacted, and they have developed protons and neutrons. After 3 minutes, the temperature dropped to 10 to 8 degrees Celsius. Okay. Still, atoms was not being formed. After 3 lakh years, the temperature dropped to around 10,000 degrees Celsius, and we have seen the formation of atoms. Okay. So, before starting Big Bang theory, we should know what are fundamental elementary particles. Okay, please prepare the notes. Big Bang theory. So first of all, we are going to discuss fundamental elementary particles. Fundamental elementary particles. Okay, fundamental elementary particles. That means what? These are the elementary particles that cannot be dissociated into any other particles. They are the most basic fundamental elementary particles. Okay. So they are being categorized into two groups. One is called your fermions. Fermions. Okay. So when you talk about the fermions, again they are being divided into two groups. One is called the leptons, and other is called your quarks. Leptons and quarks. This is called your bosons, and this bosons family, they are being again divided into gauge bosons and Higgs bosons particle. Higgs boson particles. So when you talk about the fundamental elementary particles, they are being categorized into two groups, fermions and bosons. These fermions, they are again being subdivided into leptons and quarks. Is it? When you talk about the leptons, it has when you talk about the leptons, it has what? Six members. For example, electron, non, tau, and again we have what? Electron neutrinos, it will be there in your notebook or in your PPTs. Okay. So we have discussed that when you talk about the fermions, it comprises two family. One is what? Leptons family. In the leptons family, we have six family members. Six members. These are the fundamental elementary particles. These are fundamental means elementary means what? It cannot be dissociated further. It cannot be dissociated further. Okay. And we have what? Quarks. Again, we have six family. Up quark, down quark, strange quark, and dot dot dot. Okay. These your what? Fundamental elementary particles. For example, when you talk about atom, this is an atom. In the atom, what we have? Protons, and this is the nucleus. Here we have proton, neutron, and this is what? Electron. So what we have discussed, electron is what? Fundamental elementary particle. That means what? If a question comes like, with the help of intense energy, this electron, it can be dissociated. It cannot be dissociated. It is the fundamental elementary nature. But when you talk about protons and neutrons, they are the subatomic particles. They are what? Subatomic particles. Why so? Because these protons and neutrons, when they were supplied with energy, they will be dissociated into what? They will be dissociated into quarks. Into quarks. And because of that, we have seen that the quarks are what? Your fundamental elementary particles. Done? Now, okay. Again, we have gauge bosons. In the gauge bosons, we have gluons, we have photons, we have W and Z bosons, we have gravitons, okay, it's there in your notes. For example, when you talk about the gauge bosons, they are responsible for the formation, for the genesis of fundamental elementary forces. The fundamental elementary forces that exist in the nature, it's because of what? Gauge bosons. And because of that, we call this gauge boson as sociable particle. Sociable particle. Sociable particle. If something interacts, we call it as what? Sociable particle. So these gauge bosons, they are called your sociable particle. Why so? Because they are responsible for what? Elementary forces. They are responsible for elementary forces, and because of these elementary forces, what will happen? The two particles, they will interact. Two particles will interact. Is it okay? Okay. For example, gluon bosons, quarks and quarks plus quarks, they will interact to produce what? Protons and neutrons. And for this interaction, which will be responsible? Quark. So gluon boson, quark and quark, ultimately they will interact, and on interaction they will be developing into protons and neutrons. Here you can see that we have discussed that when you talk about protons and neutrons, they are your subatomic particles, not your fundamental elementary particles. When you supply high energy, what will happen? These protons and neutrons, they will dissociate into what? Quarks. Is it? So the high energy that is being supplied, it was responsible for breaking the binding force, and that binding force, it was because of gluon boson. So the quark and quarks, they will interact because of gluon bosons. Okay. For example, the nuclear forces, it is because of W and Z bosons. Nuclear forces, it because of gravitons, it is responsible for gravitational waves, gravitational forces. Okay. So what we have seen, this gauge boson, they are called sociable particles because they are responsible for what? Genesis of basic fundamental elementary forces. Okay. Now when you talk about the Higgs boson's particle, this Higgs boson's particle, they are responsible for imparting mass to the elementary particles. They will give mass to the elementary particles. So Higgs boson's particle impart mass to elementary particles. Is it okay? For example, when you talk about this fermion family, it has what? 12 members. Electrons, tau, electron, neutrons, tau, neutron, mount. Apart from that, 6 family members belong to the quark. All of them, they are having the mass. Is it? If they were not, for example, when you talk about this gauge boson's gluon, do you think gluon is having the mass? Mass nahi. I'm talking about, do you think this particular gluons, they are having the mass? Huh? Yes, definitely. Because what we have discussed, quarks and quarks, they will interact. They are going to interact. And on interaction, they will be developing into protons and neutrons. The interaction is because of gluon bosons, and those particular gluon bosons, it is responsible for binding the quarks. So, if anything that is not having the mass, it cannot interact with any other thing. Is it? So, definitely gluon, it is interacting. It's a binding force. Why so? Because it is having the mass. So Higgs boson's particle, it is responsible for giving mass to the fermions family. It also gives mass to the gauge boson's family. Okay. Exception is what? Photons. Photon is what? It is massless in nature. It is massless. Is it? So what we have seen? Leptons family, quarks family, they are having the mass. It's because of Higgs boson's particle. Is it? Even when we have discussed about the gauge bosons, that is called the sociable particles, they are responsible for the production, they are responsible for the genesis of elementary forces in nature. Why so? Because they are also having the mass. Exception is what? Photon. Okay. Now in the universe, if we talk about what is the main forces, it's the gravitational effect. For example, stars. Those stars, they are together, they are held together because of dark matter. And we have discussed that particular dark matter is responsible for what? Gravity forces. Again, we have discussed with the galaxy cluster. A lot of galaxies, they are being held together with the help of gravitational forces, and those gravitational forces, they are being generated by the dark matter. If you just think of a case where we do not have the gravitational forces, do you think our universe can exist? Our universe cannot exist. So the existence of universe is because of what? Mass. It's because of mass. And the mass, when you talk about the mass, it was being imparted by Higgs boson's particle, and because of that, when we say in Hindi थोड़ी मोड़ी तो आती है आप लोग हल्का फुल्का, क्या बोलते हैं तेलुगु में? कुंचुम कुंचुम ना. I have worked in 4 to 5 years from 2011 to 2014 itself. Okay, again I have shifted to General Electricals and Bangalore, and finally UPSC. Kunjum kunjum, is it? Am I right? Okay. So I have learned the Telugu, लेकिन अब दिमाग में नहीं. So when we say in Hindi particularly, ब्रह्मांड का निर्माण किसने किया? Who is responsible for the creation of universe? What we say? Brahma. Is it? But presently, if I say who is responsible for the creation of universe, it's Higgs boson's particle, because it is responsible for the imparting masses to the elementary particles. See, those elementary particles, they are having the masses, they will exhibit gravitational effect, and because of the gravitational effect, we have the present universe. And because of this Higgs boson particle is called what? God's particle. Is it? We call it as God's particle. Call it as what? God's particle. Okay. This gauge boson is called sociable particle, and when you talk about the neutrinos, they are called a ghostly particle. Very difficult to detect. Very difficult to detect. Is it okay? Okay. This is a point called singularity. It existed around 13.8 billions years ago. Okay. The temperature, it was more than 10 raised to the power 45 degrees Celsius, and because of that, what? It exploded and it has released fundamental elementary particles. These are what? This phenomenon is called what? Cosmological inflation. Cosmological inflation. Cosmological inflation is what? The singularity, it exploded, it released what? Fundamental elementary particles. These are your what? Fundamental elementary particles. Fundamental elementary particles. elementary particles. Here we have electrons, neutrinos, quarks, Higgs boson particles, boson particles. Okay, so what we have discussed? Okay, so this singularity exploded called cosmological inflation. It has released fundamental elementary particles. And just now what we have discussed, this fundamental elementary particle, they have gained mass because of interaction with the Higgs boson particles. So here we have a Higgs field. Here we have Higgs field. It is present in the classroom also, and because of that we are having a mass. Is it? This is your Higgs field. For the sake of simplicity, this is what? This is called your Higgs field. Higgs field, and in the Higgs field what we have? In the Higgs field we have, these are your Higgs boson particle. This is your Higgs boson particle. Higgs boson particle. Okay, Higgs boson particle. So when during the time of even when we talk about the singularity itself, since it is having the mass, that means what? It was also existing in the Higgs field, and Higgs boson particle, it was also responsible for imparting the mass. So when during the time of cosmological inflation, when the fundamental elementary particles released, they were started interacting in the Higgs field, and in the Higgs field what we have? Higgs boson particle. More is the interaction, more is the masses that is being developed. Even when you talk about how does Higgs boson particle gain mass. So I have researched a lot, and finally what I have got, Higgs boson particle has gained mass because of interaction with other Higgs boson particle itself. After a lot of research. Clear? Now this is the fundamental elementary particle that is being released. Now at that time, the temperature was around how much? The temperature within 1 minute. Within 1 minute. Okay, the temperature was around 10 to the power 23 degrees Celsius. Okay. And when the temperature dropped to around when the temperature dropped to around 10 raised to the power 13 degrees Celsius, what happened here? Quarks plus quarks, they have what? Interacted, and they have formed protons and neutrons. And for this interaction, which is responsible? Gluon bosons. Okay, gluon bosons. So now what we have? After 1 minute, what we have? We have electrons, protons and neutrons. Electron, protons and neutrons we have, but they have not been compacted into an atom. They have not been converted into an atom. Free flow of electron, protons and neutrons are there. Okay. After 3 minutes, after what? 3 minutes, still the temperature was too hot. What was the temperature? 10 to the power 8 degrees Celsius. 10 to the power 8 degrees Celsius. Is it okay? So after 3 minutes, what we have? Electrons, protons and neutrons. In between that, quarks and quarks, they have been interacted with the help of boson's particle, and because of that, they have been converted into what? Protons and neutrons. After 3 minutes, when the temperature, how much? After 3 lakh years, 3 lakh years, when the temperature dropped to 10,000 degrees Celsius, this electron, protons and neutrons, they have been joined together with the help of electrostatic force of attraction to form what? Atom. Now here what we have? Here we have, these all are your electron, protons and neutrons. And finally after 3 lakh years, what we have? Atoms of hydrogen. These are the atoms of hydrogen. How it is informed? Electron, protons and neutrons, they have joined together with the help of electrostatic force of attraction, and this particular force, it was being developed with the help of W and Z bosons. Now remember one concept, from singularity to 3 lakh years, this is called the cosmological dark ages. Cosmological dark ages. Why? Because the light was not able to escape. Light was entrapped. Suppose this is a proper cloud of electrons, protons and neutrons. Light is there, it will strike the electrons, protons, neutrons. So ultimately light is what? Internally entrapped. But when electron, protons and neutrons, they have been joined to form the atom, light escaped for the first time. So here it's called cosmological dark ages. It's called your cosmological dark ages. Dark ages. Okay. And why? So because the light was entrapped. Light was entrapped. Okay, but here what? Light evolved for the first time after 3 lakh years because of the formations of atoms. And from here what we have? Cosmological light ages. Let us start it with cosmological light ages. Clear? After that what? Now we have atoms, hydrogen atoms. These hydrogen atoms, they will join to form what? A star. And those stars, because of dark energy, because of dark matter, because we have seen dark matter is responsible for generating what? Gravity forces. It will be forming into galaxies. This is your galaxy. And finally lots of galaxies, they will be joining into your galaxy cluster. And finally what? Super cluster of galaxies. Super cluster of galaxies. And what is the temperature of the present universe? Minus, what is the temperature? Minus 273 degree Celsius. That's the absolute zero temperature. We say absolute zero temperature because when you talk about the average temperature of the universe is how much? Minus 273 degree Celsius. So temperature is how much? Is it okay? The singularity had light. What? अब एक चीज सोचने की कोशिश कीजिए कि जो हम द यूनिवर्स व्हाट वी आर डिस्कसिंग, इट्स कॉल्ड व्हाट? ऑब्जर्वेबल यूनिवर्स. इट माइट बी अ ड्रॉप इन द ओशन. जो यूनिवर्स का एंड कहाँ है, वी आर नॉट अवेयर ऑफ इट. We are discussing about the observable universe. Observable universe means what? With the help of Hubble Space Telescope, with the help of James Webb Space Telescope, जहाँ तक हम चीजों को देख पा रहे हैं, that is called the observable universe. Just think of that. Think the present universe. It has just developed with the help of singularity itself. And when you talk about the singularity, it's clearly written that it's the size of an atom. So just think the complete size of an atom. How it would be possible for that particular atom to hold the complete mass of the universe? No answer. So, ठीक है. We'll study about variance asymmetry at the end. You'll come to know कि क्या है क्या. This thing is okay? Okay. Good question. See, when you talk about, if you go by the theoretical aspect, the singularity, it was not having any sort of light. Why so? Because it is being categorized into cosmological dark ages, first point. Secondly, what we have discussed, the light evolved for the first time after 3 lakh years when the temperature dropped to 10,000 degrees Celsius. If you go through the AI, it's approximately 3,80,000 years. Now, how those lights they will be developed? Because of the frictions of electrons, protons, and neutrons. So because of the frictions, what will happen? Heat will release, and heat is nothing. Heat is released in the form of light itself. Like earlier, when the heat was released, it was being entrapped. It was being entrapped. But when those electron, protons, and neutrons they have been coalesced, they have been condensed from the atom. We are having this space, and the light evolved for the first time. So when you talk about like singularity, it was not having any sort of light. Of singularity के पहले क्या था? We are not aware of it. Singularity के पहले भी एक दुनिया थी. When you talk about singularity, before singularity also there was a universe. Okay, and that particular universe, it was also being created from a point called singularity. So it's a what? Cyclic process. This for your notes, what we have discussed. Now, evidence of Big Bang theory. Evidence of Big Bang theory. What are the different evidence? In 1964, the cosmological microwave background radiation was discovered, which was crucial evidence in the favor of Big Bang model. For example, we have discussed that after 3 lakh years approximately, light evolved for the first time. And if we are studying those light, and we find that the age of this particular light is approximately 3.8 billion years. That means what? It is what? Synchronizing with the Big Bang model itself. Second is your cosmological redshift, and other is what? Gravitational waves. We will discuss. We'll discuss. Big Crunch theory. When you talk about the Big Bang theory, it talks about the creation of universe from a point called singularity itself. When you talk about the Big Crunch theory, it says that finally, again the universe, it will be converted into a point called singularity. For example, we have discussed about the Milky Way. At the center of the Milky Way, what we have? Black hole, that is the Sagittarius A. You must be quite aware of the fundamental aspects of black hole. Its gravity forces is so strong that even when light enters into the black hole, it cannot come out. That means what? If anything comes nearby, within the gravitational influence of the black hole, it will what? Completely absorb that particular object. So ultimately, when you talk about the Milky Way, the complete Milky Way, when you talk about the Milky Way, the complete Milky Way, it will be converted into a black hole. And what will be the black hole? Sagittarius A itself. Similarly, suppose this is the Sagittarius A, here another black hole, bigger black hole. So this particular Sagittarius A, it will be engulfed in this particular bigger black hole. And simultaneously, what will happen? Finally, we will have only one black hole. That will be responsible for engulfing the complete universe. And finally, what will happen? The black hole, since it is not getting any sort of mass, it will shrink, and finally it will get converted into singularity. Now that particular singularity, it is holding the complete mass of the universe. Because of frictions inside it, the temperature will increase, and because of the friction, again it will go for the cosmological inflation, and the creation of universe will take place. So this is called your Big Crunch theory. Is it okay? Nothing is permanent. है ना? कोई चीज परमानेंट है, सोचिए, जस्ट थिंक ऑफ इट. वी सी नथिंग इज परमानेंट, तो क्यों इतना टेंशन लेना? Take a fact. What is photoelectric effect? Photo. Okay. Einstein important theories is what? First is photoelectric effect, then we have a special theory of relativity, and then general theory of relativity. Okay. So Einstein was awarded Nobel Prize not because of general theory of relativity, not because of a special theory of relativity, but because of photoelectric effect. Okay. So Einstein was awarded Nobel Prize because of this in 1921. Okay. A special theory of relativity, it's called what? Relativity without gravity. Relativity without gravity. That means what? Einstein has not considered the effect of gravity on relativity. That's why it's called relativity without gravity. Okay. Please, I will request, just prepare the notes for this. A special theory of relativity and general theory of relativity. Okay, because do not go through the AI, do not go through the websites. When you talk about the special theory of relativity, general theory of relativity, they are the most complicated concepts. Relativity without gravity. Without gravity. He has given this concept in 1905 itself. And again, Einstein worked further 11 years. He worked further 11 years to include gravity in his equation. Earlier he has given relativity without gravity, that is a special theory of relativity, in 1905. Again he worked for 11 years to include gravity in his equation. He has given what? General theory of relativity, and because of this general theory of relativity, it's called what? Relativity with gravity. Relativity with gravity. Okay. Okay. Now photoelectric effect. Okay. Photoelectric effect. Consider this is a vacuum tube. This particular plate is called what? Cathode plate. Cathode. And this is called your anode. Anode, and this is your battery. Battery. How to remember it? Panic. PANIC. Positive is anode. Negative is cathode. Okay. Now this is a cathode plate. So what does it mean? It will have surplus electron. The electron density, it will be much more higher in comparison to the anode. Now this, suppose this is the light. This is what? Light. In the light, what we have? Light comprises of particles. See, when you talk about the photoelectric effect, what is the most important significance of photoelectric effect? It has explained the particle nature of light. Light comprises of a particle called photon particles. The particle nature of light, it was being explained with the help of photoelectric effect. So it has particles. This is called your photon particles. This is called your photon particles. Photon particles explained by this thing. Okay. Now, when you talk about the photon particles, they do not carry the energy in the continuous fashion. Rather, they carry the energy in what? Discrete pocket. We call it as quanta of energy. Okay? We call it as quanta of energy. For example, this is the photon particles. So it will carry the energy in the form of discrete pockets called quanta of energy. This is called a discrete pocket, and we call it as what? Quanta of energy. Quanta of energy. Is it okay? So when you talk about the photoelectric effect, it has explained the particle nature of the light, and apart from that, when you talk about the photon particles, they carry energy not in the continuous fashion, rather but what? In the discrete pocket, we call it as quanta of energy. Now what happens when this photon particle, they will strike these cathode plates, they will transfer the energy to the electron itself. Suppose consider it, this is a particular atom, here we have electron. So the electron, on receiving the energy, what will happen? It will move to the higher orbit, and again it will come back to its ground state. More is the higher energy, more is the orbit, and finally this is the threshold limit. This is called your threshold limit. Threshold limit. If the energy that is being supplied, if it is greater than the threshold limit, electrons will be permanently ejected. So electron will be permanently ejected. So here remember one thing, the supplied energy, it should be greater than the threshold energy of the electrons. So that what will happen, the electrons, they will be permanently ejected. The electrons, it will be ejected. These are the electrons. Electrons ejected. Electrons ejected. Why they are ejected? Because the supplied energy by photon particles is greater than the threshold energy of the electron. Threshold energy of the electron. Okay, the electrons have been ejected. What is the necessary condition for it? The condition, it should be the energy that is being supplied by the photon particles, it should be greater than the threshold energy. Otherwise, what will happen? The electron will just gain the energy to move to the higher orbit. Again, it will be returning back to its ground state. Okay. So remember, in photoelectric effect, it has explained the particle nature of the light, and apart from that, quanta energy. The two things. This is the photoelectrons that is being, these electrons, they are called your photoelectrons. Photoelectrons. Is it okay? Now, applications of photoelectric effect. What are the different applications of photoelectric effect? This digital screen itself, it is also working on the basis of photoelectric effect. CRT tube, cathode ray tube. Pehle, when you talk about the earlier TVs, the CRT tube, cathode ray tube, they are also using this principle of photoelectric effect. When you talk about this solar plates, they also use this photoelectric effect. And if you want to study the metallistic property of certain substance, there also we will be using the photoelectric effect. We will supply the energy, and because of that, the electrons, it will be emitted. We will study the emitted electrons. So these are the different applications of photoelectric effect. In the examination, always remember, if you want to study some of the materials, metallistic properties, it can be done, studied with the help of photoelectric effect. If you see certain glowing things itself, for example, solar industries, television industries, and digital board industries, they will be using your photoelectric effect. Okay. Done? theory of relativity. Relativity means what? Space and time, they are related to each other. Space and time, for example, motion is absolute or relative in nature. Motion, movement of a particular body, it is absolute or relative? It is. Why? Because it depends upon the source from which motion is being compared, and it's called what? Inertial frame of reference. If you change the inertial frame of reference, obviously what? Motion will change. For example, Earth rotates from west to east. This statement is incomplete. I have to say Earth rotates from west to east when it is being seen from the north pole. Then only west. If I see it from the south pole, the rotation it will be from east to west itself. Okay? So here we have a special theory of relativity. A special theory of relativity. Here we are not concerned with the special theory of relativity. Just to know, this special theory of relativity is applicable in the inertial frame of reference. Inertial frame of reference. When you talk about the inertial frame of reference, all the Newton's laws, Newton's first law, second law, third law, even the Newton's law of gravitation, they are applicable in the inertial frame of reference. So, special theory of relativity, it is applicable in the inertial frame of reference. That means what? All Newton's law, first, second, third, even Newton's law of gravitation also, they are applicable. Here one of the most important aspect is what? Light is not affected by gravity. Just remember, light is not, we have just discussed a special theory of relativity. So they have written relativity without gravity. Relativity without gravity, it means light is not affected by gravity. Light will always travel in a straight line, and it is not affected by the presence of gravity in its path. The most important, if you go see, only these 3 points are important for your paper. It's a prelims case course, otherwise I could have discussed this a special theory of relativity 1 hour, but no uses of that. So remember the concept. First is what? It is applicable in the inertial frame of reference. Inertial frame of reference means what? Inertial frame of reference means what? Here we have constant velocity. Non-accelerating frame of reference. For example, lift. Lift is a what? Accelerating frame of reference. It moves against the acceleration due to gravity. Is it? So it's called an accelerating frame of reference. An accelerating frame of reference, they are not your inertial frame of reference. Are you getting my point? So second, important for your paper, just light always travel in a straight line, and is not affected by the presence of mass, presence of gravity in its path. This is the most important aspect. Light always travels in a straight line and is not affected by the presence of mass, gravity in its path. What does it mean? It means that light is not affected by gravity. It means light is not affected by gravity. Consider one case particular. Suppose this is a particular star, okay, it is emitting its light. This is the light, okay, and here we have a galaxy. This is the galaxy. This is what? Galaxy. Consider this case, okay. So what we have seen, light always travels in a straight path, a straight line, and is not affected by the presence of mass galaxy in its path. That means what? Light is not affected by gravity. Is it okay? Light is not affected by gravity. Though this particular diagram, write it down. लिख लिया आप लोगों ने? Noted? लिख लिया? Very fast? और पक्का noted ना? Okay. Now, general theory of relativity. So what we have seen, the first theory, and write down one more point, E equals to mc square. E equals to mc square, it is also given in the special theory of relativity. Einstein famous theory, E equals to mc square, it's given in the special theory of relativity. America has used this particular E equals to mc square formula in its Manhattan Project, USA, for the development of first nuclear weapon during the World War II. Little boy and fat man. It was being developed using what? This particular formula, E equals to mc square. So it was being given in the special theory of relativity. So यहाँ देखेंगे general theory of relativity. So Einstein has worked again further 11 years to see the effect of gravity, and finally what he had included gravity in his equation, and that particular special theory of relativity, it has become now what? General theory of relativity. Okay, so here you can see that when you talk about the Newton's law of gravitation, gravitation is a what? Gravity is a force. Gravity is a force. But when you talk about the general theory of relativity, it is not a force. Rather, it's a what? Curved field. Are you aware of it? और सभी को पता है और I have to explain. पता है? Say yes or no. If you are not aware of it, please say yes or no. पता है आपको? General theory of relativity. So, relativity without gravity. Relativity with gravity. Is it? With gravity. To explain this particular concept, what? We have to use a space-time continuum. A space and time continuum. If you want to study any sort of event, either it is gravitational waves or light or anything into the space, we have to use space-time continuum. Okay, so this is the space. Suppose this is your space-time continuum. Space-time continuum. So this is the space. This is what? Space. And this is your time. This is your time. Time is the fourth dimension. Remember, fourth dimension, because when you talk about the space, already we have x, y, and z axis, and when you talk about the time, it's the fourth dimension. Okay, so this is what a space-time continuum. Now, this particular thing, it is applicable for empty space where we do not have any sort of masses. So it will be appearing like this. But when we talk about when you talk about the general theory of relativity, it says that gravity is not a force, rather it's a what? Curved field. When you talk about a force, for example, gravitational force, it is being explained by the Newton's law. Newton's law says that if you are having two bodies, M1 and M2, obviously what? Gravity forces, it will be there. And that particular gravity forces, it is directly proportional to the product of the masses, inversely proportional to the square of the distance between them. Are you aware of it? Okay, for example, we have two bodies. This one is your M1 and this one is your M2. As per Newton's law of gravitation, the forces of gravity that is existing, it will be what? Directly proportional to the product of the masses, gravitational constant M1 M2 upon R square. Is it okay? Clear? So here gravity is a force, but as per general theory of relativity, gravity is a what? Gravity is a curved field. Curved field. Okay. For example, now this particular concept of space-time, it is valid for the empty space. Now consider this example. Suppose we have a galaxy over here. Suppose this is what? Galaxy. So when you talk about the galaxy, a lot of stars are there, and because of that, it will having its mass. It will have mass, and since it is having mass, it will exert what? Gravitational effect in the form of gravity forces. Gravity. But here in this case, gravity is not a force, rather it's what? Curved field. Because of this, what will happen? The space will get curved. Space fabric, it will get curved. This is what, because of the gravity, what we can see, curvature of space, and time slows down in the presence of gravity. Time will, what will happen? Time slows down in the presence of gravity. Time slows down in the presence of gravity. Is it okay for everyone? For the purpose of explaining this general theory of relativity, we have to see the concept of space-time continuum. It's an invisible network. It's an invisible network. Okay. So gravity, it was a force in accordance with the Newton's law of gravitation, but actually in the universe, it's a what? Curved field. It's a what? Curved field. You can see that because of the presence of this particular mass, gravity, what we can see, the curvature of space. More is the mass, more is the curvature of space, and time slows down in the presence of gravity. Is it okay? So now we will see its application part. सभी बच्चे मतलब फाउंडेशन कोर्सेज आप लोग कर चुके हैं, क्रैश कोर्स ही है ना आप लोग का, इज इट? यहाँ देखते हैं, फॉर एग्जाम्पल time slows down in the presence of gravity. From here what we have concept of gravitational time dilation. From here we have the concept of gravitational time dilation. Gravitational time dilation. Gravitational time dilation. For example, this gravitation, if I ask you this gravitational time dilation concept, it is applicable in the satellites, is it? Is it? We are using this particular concept of gravitational time dilation concept. It is applicable in the GPS system. It is applicable in the geospatial technology. Is it? What we have seen, gravity, time slows down in the presence of gravity. For example, on the Earth's surface, we are having a clock. Okay, and apart from that, when you talk about the GPS satellite, when you talk about the geosynchronous satellite, they will also having the clock. Do you think the timings it will be same? Time it will be same. Time it will be faster in the. It will be faster in the satellite clock itself. So, and because of this, we are using atomic clocks. We are using what? Rubidium-based atomic clocks. Because when you talk about the rubidium-based atomic clocks, they calculate that time with the help of its oscillation. They seem to be very much accurate. Approximately, they are ahead by 32 milliseconds, and they have to be adjusted in the telemetry center of ISRO, Bangalore itself. Okay? This is the gravitational time dilation concept. And you must know that this gravitational time dilation concept, we know it earlier also. When you go through this Mahabharata itself, there a story is there regarding the Lord Krishna itself. Lord Krishna, he was playing with his fellow mates, he was playing with his friends. But Brahmaji, he was not believing that this is a particular god and he is playing with his friends. So what he did, उन्होंने सारे दोस्तों को उठा के जो he took it to Brahmalok. He took it to Brahmalok. वहाँ पे he just take a power nap around 10 minutes. और अर्थ सरफेस पे कितना हो चुका था? 4 months itself. 4 months itself. So it clearly says the concept of gravitational time. When you talk about the Brahmalok itself, बहुत ज़्यादा distance from the Earth, so obviously time it will be very much faster. But when you talk about the Earth surface में क्या होगा, time it will be much more slower. And because of that, on the Earth surface we are having 4 months, and there we are having 10 minutes. So there the concept of gravitational time dilation concept is applicable. Even one of the mysterious place in the universe is your Gyanganj, place of Shangri-La. पढ़े आप लोग? Gyanganj, place of Shangri-La, Shambhala city. पढ़ा है? Not in that movie Kalki Avatar. Okay. There is a place called Gyanganj, a place of Shangri-La. It is existing in the Himalayas. It is existing in the. I'm not talking about this mysterious place. Yes, I can explain the scientific conditions over there. Now, when you talk about the Himalayas, generally in Puranic Vedas or something, we say that the complete mass of the earth, it is concentrated in the Himalayas itself. We say it? Yes or no? Now, beneath the Himalayas, there is a place called Shangri-La. There is a place called Gyanganj. Okay, now just consider the fact, if that particular Himalayas, it is what? It is holding the complete mass of the earth. Obviously, was gravity, it will be much more higher. Gravity is much, and because of the gravity, what will happen? Time slows down in the presence of gravity. And it is being said that you must be knowing about the 7 immortals. Hanumanji, Parsuram. Is it? These are the 7 immortals. So what I say, they are residing in that particular place itself, place of Gyanganj, place of Shangri-La. Because what you can just consider, go by the science itself. If you talk about they are being developed, this particular city, it is existing beneath the Himalayas itself. It was holding the complete mass of the earth. So because of that, we are in intense gravity, and because of the intense gravity, time slows down in the presence of gravity. Time is extremely low over there. वहाँ का 100 years, it will be equivalent to 100 years. It will be equivalent to 1 days. So there you can talk about the Parsuram and all those things. They are. If you go over there, they are still healthy and young. Even if you go through the history itself, I should not, because I'm not a history faculty. Hitler said to Subhash Chandra Bose, if you want the freedom, please, I want to visit the place of Shangri-La itself. I want to see. It's a very mysterious places. The people, they used to see that it is existing in the 8th dimension, and normal people, they cannot visit over there. Some of the people, they have visited over there, but in the meditative state. Meditative state means they will go to the Himalaya, they will start the penance, and finally what? They will lose their consciousness, and they will be in the meditative state, and in the meditative state, they will visit over there. It's a story or whatever it is, but jo tha maine bata diya. I have explained the scientific factors. Okay. So gravitational time dilation first. Second is what? Curvature of space. And because of this curvature of space, we have the concept of gravitational waves. We have the concept of gravitational waves. We'll discuss this. Gravitational waves. Okay. And apart from that, using these two concepts, you know a bit about the black holes. Black hole, ultimately, when you talk about the particular bigger star, at the end of its life cycle, it will get converted into what? A black hole. When you talk about the black hole, all the masses of the star, they will get squeezed to a point called singularity. And that particular point is called what? It's a black hole. And because of this, since all the masses of the star, it is being squeezed to a point called singularity, it is having intense gravity. And the gravity is so intense that even the light, when it penetrates into the black hole, it cannot come out. So now, if you can see, suppose this is a black hole. This is what? Black hole. Black hole. So black hole is having intense gravity, and because of this intense gravity, it will have infinite curvature of space. So this is the infinite curvature. Is it? Infinite curvature of space? Is it? Clear? And what? Time does not exist. Time slows down in the presence of gravity. In the black hole, we have intense gravity, and because time does not exist, here time does not exist. Is it okay? And this infinite curvature, it is acting as a gravitational well. It is acting as a what? Gravitational well. Okay. Now, if we say that if some celestial object comes under the influence of a black hole, what will happen? It will be engulfed inside the black hole. So, why? Because this is the celestial object. If it comes inside the black hole, what will happen? It will start and finally it will merge inside the black hole. एक well हो गया ना? This is a well. Obviously, what suppose this is a black hole and this is the well. If something comes under the influence, ultimately it will become the part of the black hole itself. Now, third is your third concept. The most important one is what? Light is affected by gravity. A special theory of relativity, what we have discussed, light travels approximately at the same speed. Light will always travels in a straight path. Light always travels still a straight path, and it is not affected by the presence of masses or presence of gravity in its path. But here, light is affected by gravity, and we say mass bends light. Mass bends light, and from this we are having concept of gravitational lensing. Gravitational lensing, and one special case is what? Einstein ring. Okay. So all these particular concept, they are being derived from the general theory of relativity itself. Okay. We'll take the break. Want to continue? ब्रेक का टाइमिंग क्या आप लोग का? 12:30 to 2. Okay, we'll start the classes from 2 and we will extend up to 4:38. Are you enjoying the session? मजा आ रहा है सभी को? See, it's a rapid crash course. So my theme, मेरा purpose क्या है? I have to explain all sort of fundamental concept, and apart from that, we will be discussing the current affair itself. Okay? So, thank you. Which one? This is light is affected by gravity, mass bends light, and from this particular statement, see, in the general theory of relativity, if you go, this particular statement is being used by the Albert Einstein. Mass bends light, that light is affected by gravity, and from this particular concept, what we have? Gravitational lensing, and the other is what? Einstein ring. For example, now this is a particular star. Now this is the particular star. It is emitting the light. In its path, suppose there is a galaxy. There is a galaxy. This is what? Galaxy. What will happen? Light will bend. So now light is affected by gravity. Mass bends light. Is it okay? We'll take the break and we'll start with 2 minutes.